then how to find decimals. So yeah, so let's do that. This video should be pretty quick. Oop, there we go. Open the whiteboard. So the way you go between decimals, percentages, and fractions. So let's do this. So we got fractions to decimals is pretty straightforward. You literally just divide by the denominator. So for example, if I have 3/4, just checking how many times 4 goes into 3. You can certainly use a calculator for this if you want to. That's going to be, in life, your most common thing to do. One thing that's really nice to do, though, is to get better at, or is to do the operation yourself without a calculator, so that you remember what the number is. Right, like I'm guessing almost all of you knew that 3/4 was 0.75. Right, but you can do that with other things as well. And knowing really common ones is very helpful. So for instance, know your halves, thirds, fourths, and ideally fifths. And I think you're probably good from there. Yeah, I would say that that's probably all you really need, at least in an effective sense. Right, you can use, if you get 7/13, I don't know what 7/13 is. Feel free to use a calculator as far as I'm concerned. But that's how you turn fractions into decimals. Decimals into percents is really easy. You just move the decimal place. One, two. And the way you convert fractions into percents is you convert them into decimals, and then the decimal into a percent. You just do it in a two-step process. And just get used to like thinking of 75%. Well, that's 0.75, which is 3/4, right? Going backwards is, I mean, you can, right? So if I have 0.75, that's the same thing as 75 over 100. It's got 2 decimal places, so that's over 100. If it had 3 decimal places, it'd be over 1,000. It's 1 0 per decimal place. And then you reduce this fraction, right? So 25 goes into both of those. Here, let me do this. And so that's how you go from fractions to percent, or fractions to decimals to percentages. And it's also how you go back, right? If you have 75% and you want to turn that into a fraction, the thing to do is think 75% is 0.75, and then 0.75 is 3/4, right? You can just convert it this way. This always works, by the way. It's a little I don't want to say awkward, but you have to get used to reducing fractions a lot if you want to go decimals to fractions. It's harder than the other way around. That's pretty much it for converting between them. That really is all there is to it. If you want to find percentages of things or fractions of things, the way to do it is by multiplying. As I mentioned in a fractions video, of means times. And so if I want 2/3 of 6, the way I like to think of that is I like to think of that as this 3 tells me that I want to divide this thing into 3 pieces, and then this is how many of those pieces that I want. So if I divide 6 into 3 pieces, each of those pieces are 2, and then I want 2 of them, so that's 4. You can also just do this. That's 6 times 2 over 3, which is 6 over 1 times 2 over 3, which if I cancel, I end up with 4 over 1, which is 4. Right, and so that's the easiest way to do it mathematically, is just if I want something of some amount of something else, the of means times. So let's say I have dishwashers on sale for, let's say, 40% off, right? And it normally costs $350. So I want to find 40% of 350. Well, I'm going to multiply, right? The of means times. So I'm going to turn that into a decimal and then multiply. That is 0.4 times 350. And then you can calculate that out. Let me show you a thing that I like to do when I'm multiplying here. So you can move this decimal place one this way and then this one the opposite direction. If you're multiplying stuff and you move your decimal places in the opposite directions of each other, the same number of times, it works out. Now, you might say, well, that sounds very suspicious, Jeff. Why can't you just do that? It's because I'm multiplying by 10 and dividing by 10, right? So let me show you what that looks like. So if I have 0.4 times 350, 0.4 is the same thing as 4 divided by 10. And 350 is 35 times 10. So divided by 10 and times 10 cancel each other out. So if I'm multiplying this divided by 10 and times 10 cancel each other. And so I get 4 times 35, which that one I can do in my head. 4 times 30 is 120. 4 times 5 is 20. So 120 plus 20 is 140. You can also, again, I'm not scared of calculators. You want to get good at doing math well in your head, because that will just let you understand things easier. If you have to go to a calculator for every single simple calculation you're doing, it makes it so that when you're doing a simple calculation in a larger context, it makes it hard to grasp the larger context if you're constantly being interrupted to go to the calculator. So if you want to learn things, better, make sure that you're very good at the foundational stuff, right? So that by the way is why math teachers are often anti-calculator, is because when we get to rational expressions, for instance, and we're dividing stuff all the time and we're multiplying by fractions all the time, if you have to go to a calculator every single time, it's going to make it very hard to grasp. And so you want to be generally good at calculating things, which I probably don't have to sell you on. You knew I thought that, right? I'm a math teacher. And so while we're doing this, I'll give you all the tricks that I use to multiply, add, subtract, multiply, and divide in a relatively simple manner. This is the first one. Don't get too caught up in decimals. You can always fix them later. You can also sometimes fix them in the middle of the problem, like this, right? If I got a decimal here and an extra 0 there, I can just cancel them off, basically, right? I can think of this as 4 and 35 rather than 0.4 and 350. And 4 times 35 is easier, right? So 140. So that means that my theoretical dishwasher that was 40% off is $140 off. Remember, it was 40% off. And so the actual cost would be 350 minus 140, which is 210. That is really about all there is to finding percentages of things. One thing I will mention is that a number like 1.5 is 150%, right? You can have percentages larger than 100, obviously. You don't encounter those too much in everyday life. It's usually between 0 and 100, but it doesn't have to be, right? And so any number bigger than 1 is bigger than 100%. 1 is 100%, right? That gives you sort of an anchor point to think from, right? 1 is 100%, so any percentage that's under 100% will be under 1. 70% is 0.7, for instance. And any number bigger than 1 is bigger than 100%. So 3.7 is 370%. And those will correspond with fractions that are bigger than 1 as well, right? This is 150 over 100, which is 3 over 2. Reduce it. So this number will be bigger than 1 when this one is bigger than 100%, when this one is bigger than 1. So just a little anchoring point there. And I think that's really all I want to say about percentages and decimals. Let me make a quick check here. There's one trick that I put on the homework, which is finding percent of a number is the same as finding the number of the percent. And let me show you what I mean. So if I'm finding like 18% of, let's say 30, that's exactly the same thing as 30% of 18. Those really are completely identical. So the reason for that, let me use the literal translation of percent. Per means divide, and cent is the Latin for 100. I don't think that's the actual Latin word, but it's the root, right? So 18% is 18 over 100. That's literally what it means. 18 parts out of 100. So if I'm taking 18% of 30, that is 18 over 100. Of course, of means times 30. Well, 30% of 18 is 30 over 100 times 18. So you can see that in both cases, what we've got is 18 times 30 and then divided by 100. And here I've got 30 times 18, which is of course the same, divided by 100, right? We're just dividing by 100 in both cases. It doesn't matter where the divided by 100 goes, right? Whether it's first or second is irrelevant. So 18% of 30 is exactly the same thing as 30% of 18. Well, for the reason I just said. And so I imagine when you saw 18% of 30, you were thinking, I don't know how to find 18% of something, right? That's a weird percent. And it is, but you can ignore it, which is the nice part, right? So I can just do 30% of 18, which is 0.3 times 18. Right, so 30%. So this is the same thing as 0.18 times 30, which is exactly the same as 0.3 times 18. And you can do either one of those, whichever one you like. And it really doesn't make any difference. Sometimes, so some things like, 50%, like if you're looking for 32% of 50, you might say to yourself, I don't know what 32% of 50 is. Well, do you know what 50% of 32 is? Probably, right? That's half of 32, which is 16. So sometimes it's easier to move the percent around depending on what kind of number you're dealing with. So I find this this method of thinking about it in the opposite direction sometimes pretty useful. And 30% of 18 is what, 5.4? Yeah, it's 5.4 because 3 times. So again, let me show you the trick I used there. What I'm doing when I do 30% of 18 is I'm pretending this decimal isn't even here. I'm just doing 3 times 18 and say, okay, 3 times 18. I know that's 54, but I have an extra decimal place. So it's 5.4. That's it. That's all I did there. So I don't necessarily know off the top of my head what 30% of 18 is, but I do know what 3 times 18 is because I know my times tables. And then I just add in however many decimal points I need, right? So 3 times 18 is 54, but in my original problem, I had 1 decimal point or one decimal place. So I need to use 1 decimal place in the answer as well. And so that's what we get. All right, I think that's all I really wanted to say. Just to recap, go between fractions and decimals, you just do the division, right? 3/4 literally means 3 divided by 4. So you just divide 3 by 4. And that'll give you the decimal. To turn a decimal into a percent, you move 2 decimal places. 0.75 is 75%. If you forget which way to move the decimal place, by the way, and that's a very easy thing to do, the thing you want to remember, at least the way I do it, is I realize that decimals are relatively small, right? They tend to be under 1, whereas percents are relatively big. They tend to be like around 100-ish. And so to make decimals into percents, I need to make the number bigger, which is what I'm doing when I'm 0.75 turns into 75. And then go from fractions to percents. You just go through decimals. At least that's what I do. There's probably some other quick way to do it, but I don't know what it is. Oops, I need to make a new one. I meant to go here. To turn decimals into fractions is kind of a pain in the neck, to be honest. But the way you do it is you identify the number of decimal places that you have, use that as your denominator. So 0.75 has 2 decimal places, so I need a number with 2 zeros, so 100, and then I reduce the fraction. And then fraction of something, percent of something, the of means times. Oops, I did not mean to draw that. The of means times, and that's so just multiply 2/3 of 6, 2/3 times 6. 40% of 350, 0.4 times 350. And gosh darn it, don't get too caught up in number of decimal places for the multiplying. It's important to remember, but like if you have something like this, 0.4 times 350, you can sometimes rearrange your decimals like this to make it easier, right? I remove a decimal place here, and so I add another one there, and that's okay. And then use the same principle with percentages. This is really just removing 2 decimal places here and adding them over there, right? So 18% of 30 is 0.18 times 30. Well, I can think of that as removing 2 decimal places here to get 18 and adding 2 decimal places here to get 30%. So it's actually the same trick that I used up here. It's just you're just doing 2 of them to give you that. All right, I think that's the last thing I wanted to say. So I'm going to go ahead and stop the recording now. Oop. Sorry, I'm a little awkward with this. And then I will go ahead and see you in the next video.